My tutorial in this time we are solving kinematics is from Cambridge Admit book exercise 16.2 and page number is 418. It's a little bit challenge question, not that much hard. I think if you have done all kinematics then it is easier if you know the rules of the kinematics. Question number 12, exercise 16.2. It is written there a particle moves in a straight line so that t seconds after passing through a fixed point O, its acceleration a is given by a equals to pt plus q. Acceleration expression is given, and where pq are constant, the first part is written the particle passes through O with velocity 3 meter per second. It means that when t equals to 0, its velocity is 3 meter per second, and acceleration minus 2, and also when t equals to 0, its acceleration is also minus 2 meter per second square. That's the information given or provided. And another information, the particle first comes to instantaneous rest when t equals to 2. So you can say when t equals to 2, its velocity equals to 0, because we know when particle first comes to rest or instantaneous at rest, then we should consider v equals to 0. Let me start the equation how to solve it. So first we will put here in this expression when t equals to 0, acceleration equals to minus 2 in the main expression. It is written here. We are doing the first part. A is given minus 2 in the equation we are writing, and value of t equals to 0. So let me put the value of t, p into 0 plus q. So we already have the value of q from here by putting only the acceleration, q equals to minus 2. This is one answer of the first question. Then the second part of the question is little bit longer, I think, in this time, because we needed to convert the acceleration part as a velocity. We have to integrate now. Let me integrate. V equals to integration of pt plus q dt. So we also put the value of, instead of q we can write here q equals to minus 2. Let me write it minus 2. Now we are doing integration of that part, and it gives us pt square by 2 minus 2t plus c when v, velocity expression. So in that case we can put this value to get the constant c from here, and or we would get one equation from there. When v equals to 0, t equals to 2. So let me put here v equals to 0, t instantaneous rest, it is written that t equals to 2. So p into 2 square divided by 2 minus 2 into 2 plus c. So it gives us 0 equals to, we can cut out 2p minus 4 plus c. So our equation is 2p plus c equals to 4. So you can write that's the first equation. And the part is when t equals to 0, v also 3 meter per second given there. So let me put also that part. When t equals to 0, v equals to 3 meter per second. Let me put 3 equals to t equals to 0. It is, we got from here p by 2 into 0 square minus 2 into 0 plus c. So the two terms become 0, so therefore you can write c equals to 3 from there. 0 0 c equals to 3. So if we put in this value in equation number 1, from 1 we can find out 2p plus 3 equals to 4. So from there we can find out p equals to half 1 by 2. So we got the two value, and we already have done the first part of this equation. P and q they're asking, so the q value is here and p value is here. So now we are going to move to the second part, part B. Find an expression in terms of t, the displacement of the particle. So we have to integrate again the velocity part to get the displacement. Velocity expression after putting the value of p and c and t we got from there. I'm writing below. B equals to, you can write p value we got half, so half into t square by 2 after putting that p value, then minus 2t, and c value is, we got the c value 3, so let me put here c value is 3. Now our expression is 1 by 4 t square minus 2t plus 3. So to get to the expression of displacement we have to integrate. Let me integrate again, and we can express as s integration of 1 by 4 t square minus twice t plus 3 dt. So let me integrate, and it would gives us 1 by 4 into t 3 by 3 minus 2 t square by 2 plus 3t and another constant plus c. So we can write it 1 by 4, 1 by 12, 1 by 12 t to the power 3 minus, we can cut out this, t square plus 3t plus c. This is the displacement expression, but we need to find out the value of c. It is written here, it started passing through the point fixed point 2. It means that when t equals to 0, we can write here, when t equals to 0, s is also 0. So let me put this value in the expression. So s equals to 0 equals to 0 minus 0 plus 0 plus c. So from there we would get from there c equals to 0. So our displacement expression we can write s equals to 1 by 12 t cube minus t square plus 3t is the expression for our displacement. Hope you understood the questions we have done. If you have not done the all other question from 16.2, you may see my other tutorials. I have done maximum questions from there, so you would get the idea, normal idea. Then you should come in this challenge question. Okay, the next question is the velocity. Find the second value of t, the particle, when the instantaneous at rest. So we have one velocity expression. This is our velocity expression, so we should consider another for the another value of t, v equals to 0. Let me do that. C, question part C I'm doing here. So we're considering that expression 1 by 4 t square velocity, because instantaneous rest means always we need to consider velocity equals to 0. 1 by 4 t square minus twice t plus 3. It was our velocity expression. So let me simplify and solve it, which is t square minus 8t plus 6 equals to 0. It would not 6, so we have to write here 12, because 3 4 is the 12 equals to 0. Make the LCM. Then we would get from here two factor. I think one is t minus 6. It's a normal middle term break. Please do it yourself. T minus 2 equals to 0. Then two values of 2 we are getting from there 6, and another one is 2. So the value of t2 it is given there when this is the expression it is given, but so another value of t we should consider. In that case answer we need to consider t equals to 6 is the another value of t from this expression. So we have done till to part C. Now we are moving to part D. Find the distance traveled during the 4th second. So we need to find out the displacement at 4 and displacement at the 3's, and difference would give the answer. And 4th second actually velocity becomes 0 2, another velocity becomes 0 at the point 6. So we can go directly expression of s by putting the value, we would get the answer from there. So we can write here, and question number D I'm doing here. We have to s4 minus s3, and this is the value actually from 2 it goes turn back because velocity equals to 0, then till to 6 it will turn back again. So the expression will be looks like that. I'm writing here with the different color. to make you understand. So we can write the expression like this. It is going first right way, then it's turned back, and then again it is going like this way. So we can say this is the value t equals to 2. At that moment t equals to say 4. Sorry, this is the value t equals to 6. So our 4-second distance probably here 2 to 4, 2 to 6. So this difference actually makes the difference of the 4-second distance. So that's why we would get the displacement negative from there. So let us do that by putting the value of 4 and 3 in the displacement expression. This is the displacement expression. We would get the answer from there. So let me do it, which is 1 by 12 into 4 to the power 3 minus 4 square plus 3 into 4. That was the expression, 3 into 4. Then we have to do that one. This is the first part, then minus of the second part is, we can write it 1 by 12, which is 3 to the power 3 minus 3 square plus 3 into 3 plus 3 into 3. Yep. So let us do that part, and inside you need to use calculator. Please check with your calculator. If you get the different value, please let me know. It would be minus 11 by 12 if you use the calculator. Then we needed to make this value positive, 11 by 12, and this is our answer in this stage. And we can write the answer in the, because they're asking this distance here, so this is the meter. So hope the way I did the question you understood properly. If you have any questions or any alternate method, you may write in the comments below. Thanks for watching with patience.